Okay, so this is a continuation lesson from our previous lesson where we solved only two examples while we were looking at forming the equation between quantities. Let's switch over to our writing board and continue from question number 3. So great. Question number 3. The force F acting on a conical pendulum depends on the mass m, the velocity v, and the radius r of the horizontal circle. Derive an equation relating F, m, v, and r. So that is another way of putting the question. Great. The first thing which we are required to is to look at the subject and the dependent quantity. And so far, you could easily identify that the F, that is the force, is the subject. The dependent quantities are in this order: M, V, and R. Great. From this, you will have to form a relation between the terms, and that will be F is related to the product of M, V, and R. You then have to raise the dependent quantities to some power. Because there are 3 of the terms there, I will use S, Y, and Z. So that will mean M carries S, V carries Y, then the R carries the Z. Great. From this, you form solvable equation. And that is done by simply replacing this with an equal sign and a constant K. Then M exponent S, V exponent Y, R exponent Z. You then write these terms in their dimension, and that would be the dimension of the force F equals K is a constant, then dimension of M exponent S, dimension of the V exponent Y, then the dimension of R exponent Z. Great. From this, we then have to expand the dimension of each dimensional term there. So the first one is the F, which is said to be the force. Force has the dimensional equation as M L T exponent minus 2. Then the next is the M, which is said to be the mass. The dimensional equation is a capital M, followed by V, and this V is defined as velocity in the question. And velocity has L T exponent minus 1 as its dimensional equation. And the last is the R, which is said to be the radius. Radius here expresses a length, and so its dimensional equation is a capital L. Now with this expanded, let's substitute that into the main equation, and I mean this equation. So that will be like, for the place of F, we'll have M L T minus 2 in a square bracket equals the K. Then for the place of the mass, a capital M. to the power s. For the place of the v, lt minus 1 to the power y. And for the radius, l to the power z. So you take notice of this very well. You then expand the right hand side while the left hand side is maintained. Now expanding it, that will be m exponent s. For this, the l and the t will all carry a y. So l exponent y, t exponent minus y, because the powers are multiplying. And lastly, l exponent z. So take notice, we've not done this before. So take notice of this first example. Okay, equals k. Now if you look at the m, it has got no other m than what is there. And so it goes still as m to the power s. Now the l, there are two l. One carries y, the other carries z. And they are multiplying. Remember the rules of indices. When you have two terms multiplying, their exponents are added. So that will be L is written, then exponents are added as y plus z. Then to the t, negative y has not got any other t. From this context, you have to only compare. Let's start with the m. On the left hand side, m carries a positive 1. M to the power 1. But on the right hand side, m carries an s. That will mean I can confidently say that 1 is equal to s on basis that the bases are the same, or on the criteria that the bases are the same. So I can simply say s is equal to 1 in this context. Let's compare the l on the other side. On the left hand side, l carries a positive 1, but on the right hand side, it is l carrying y plus z. This translates into an equation like 1 is equal to y plus z. Great. We don't know the value of y on the z, so we cannot continue. However, we can go ahead and compare the values of t on the other side. On the left hand side, t carries negative 2. On the right hand side, it carries negative y. And so we can say negative 2 equals negative y. You divide both sides by negative 1, then you will have y to be equal to 1. Okay, that is a negative 2 divided by negative 1, giving a positive 2, rather. Great. So we now have s to be 1, y to be 2. What of z? From this equation, that is 1 equals y plus z, we can now find z to be equal to the y moved to the side, 1 minus y. Therefore, z is equal to 1 minus, then the position of y is 2. So the value of our z becomes 1 minus 2, amounting to negative 1. So friends, we now have the values of s to be equal to positive 1, y to be equal to positive 2, then the z to be equal to negative 1. With this, easily we can substitute. and find the main equation. So I have created some space by deleting some few ones here. Knowing the values which we now know, we could go back to this equation and say F, that is the force, is equal to K unknown, M exponent S, which is positive 1, V exponent Y, which is 2, Z or R exponent Z, which is negative 1. Now let's take K to be equal to 1. At times you are given, at times you are not. Okay, so in that in place, you could say F is equal to K, which is now 1. M to the power 1 is still M. V to the power 2 is still V squared. Times R to the power negative 1 is 1 on R. That will afford us the formula mv squared over R. So this is the relation between F, mv, and R. Because you are now on your academic journey upwards, by the time you get to the very end, you realize that this is the formula for calculating the centripetal force. Thank you very much for following. Until then, this is how the whole thing is. Let's take another question. Question number 4. The hydrostatic pressure P in a container depends on the density rho of the liquid, the height h of the column of the liquid, and the acceleration due to gravity g acting on the liquid. Using dimensional analysis, show that the terms are related by the expression P is equal to rho hg, where k equals 1. Great. So this is the question for us to identify both the subject and the dependent quantity. And obviously, the subject is the P, the hydrostatic pressure. That is P. The dependent quantities are the density, rho, comma, the height, h, and the acceleration due to gravity, g. With this, you build a relationship between the quantities, and that will mean P is directly proportional to rho h g, the product of the dependent quantities. The next is you raise the dependent quantity to some power. That will be P then I'll still use S, Y, and Z. So rho to the power S, h to the power Y, then g to the power Z. We form solvable equation by replacing this with equal sign and a constant. So P is now equal to K, then rho to the power S, h to the power Y, g to the power Z. Then you write these in their dimensional form, and that will be because P is pressure, we enclose it in 8-dimensional form like this. K is dimensionless. Then the density also in 8-dimensional form, exponent S, the h height, exponent Y, and the g to the power Z. Let's take time to expand these ones, especially P is said to be the pressure. And I trust that you still recall that pressure has the dimensional equation m L exponent negative 1 T exponent negative 2. That of the density rho is also m L exponent negative 3. The h, which in the question is said to be a height, is a length, and that is a capital L. Then lastly, the g, the acceleration due to gravity, has got LT minus 2. So you see, your task is you should know the dimensional equations, as we did take time in lesson number 2, and we looked at about 17 of these. Let's now substitute into the equation. This equation. Great. With the pressure, it will now be m L negative 1 T negative 2 equals K. Then the density is m L exponent negative 3 exponent S. That of the height is L exponent Y. Then the G, L T minus 2 exponent Z. Expanding the right hand side, the left hand side remains the same. M L negative 1 T negative 2 equals K. This will be the power S goes for both M and L. So that will be M exponent S, L exponent negative 3S. So take notice. For us, this one will be L exponent Y. And the last one, the Z goes for both the L and the T. So L exponent Z, T exponent minus 2Z. Good. The left hand side remain the same, but we expand the right hand side. Let's pick M. With the exception of the M to the power S, there isn't any other M. So it carries the power S. But if you look at the L, you have 1 exponent negative 3S, Y, and Z. And all these three are multiplying. And so the exponent will be added as negative 3S plus the Y, then plus Z. That is for L. For the T, we only will have negative 2Z. Great. From here, we have the answer to compare common terms on both sides. And the first term we want to compare is M. On the left-hand side, M carries a positive 1. But on the right-hand side, it carries a positive S. Based on that, you could say S is equal to 1, since the exponents are the same. Let's also talk about the L. With the L, left-hand side, it carries L to the power negative 1. The right-hand side, it is L exponent negative 3S plus Y plus z. This will generate an equation as -1 is equal to -3s plus y plus z. And this equation needs to be solved when the value of y and z as well as s is known. Already we know the value of s. So let's wait for the value of z and y. With the t, on the left hand side, t carries -2. That's on the left hand side. On the right hand side, it carries -2z. They generate an equation like -2 is equal to -2z. Divide both sides by -2 and z is equal to 1. So now we have the value for s to be 1, z to be 1, is left with y. And we can get so from this equation. Let me create space. Picking it up from the previous page, we end up getting s to be 1, y to be 1, then this equation. Picking up from the previous page, we had s to be 1, z to be 1, and this equation. You could easily say that we could form or look for the value of y by substituting s and z. So into this equation, we can say -1 equals -3 times s, which is 1, plus y, plus z, which is 1. Have a -1 equals -3 plus 1 plus z. So -1 equals this, and that will amount to -2 plus y. The -1 plus 2 equals y. Plus 2 because -2 crosses the equal sign. Then -1 plus 2 is still 1 equals y. Therefore, y is also 1. Thank you very much. And that will mean that from this equation, when we substitute into the equation, that is, the value of the pressure is equal to K, then rho to the power S. Rho has got the power S to be 1, then the H to the power Y. Y is also 1, then the G to the power Z, which is also 1. So G to the power Z is also 1. That will mean that we can confidently say that the pressure is equal to K rho H G. However, you are told that K is equal to 1. When that is taken into account, K is equal to 1, we will then say then the pressure is expressed as rho density H G. And hence, we have proven the equation we're asked to show. Thanks very much for your audience for this as well. So, in order to check your understanding of what you have learned so far, these are 4 assignments for you to try. Pause the video, write them down, and solve it into detail. In the next video, I will take time to solve it all. Till then, stay blessed, and we shall meet again.